Yes, good morning. Can we have some people unmute their mic so that we can hear from the house? We
Good
have
morning, Doc. How's the
good morning.
family? How's
Good
work?
morning, Prof. Good morning, Prof. Everything is fine at my end. Thank you. And yours? How is
Well, we are good. We are good. We are doing fine.
thank good, thank good,
Mhm.
thank good. Let's have more people unmute.
Good morning, Dr. Rita.
Good morning, Ma.
Well done, ma. How is the
Thank
family, ma?
we thank God, we thank God.
Well
We are
done,
doing
ma.
fine. How is your family
Thanks for the
too?
webinar, ma. We are fine.
Thank God,
Thank
thank
you, ma.
God.
Yes, ma.
The truth is that it's not convenient, but it's something we have to do, okay? Yes, it's something we have to do. And thank God for Professor Layinka, who has been pushing, pushing, pushing. I'm telling you that it's not exactly convenient for anybody. The truth is, there's never a convenient time to do something, but you just have to make it happen. So, Prof is traveling, he's on transit at the moment. He won't be able to join today. The last time it was the same. In fact, it's always never convenient, but somehow we just thank God for helping us, to gather and also to share. So that's the most fulfilling part of it, and to ensure that everyone is making progress in their various space. So that's basically it. I think we should just start because today it's more like um we want to engage, we want to evaluate. It's practically the last webinar for the year. December, it's holiday. Okay. So we should start like we want participant to tell us how much they have learned from these webinars. Have we been making noise? Have we been fooling ourselves? Have we been really making impact? And have we been able to use what we have been learning in our various space? It doesn't have to start very big, but then have we been using it? Yes. So a bit of feedback, and then would proceed with a little bit of hands-on from the last tutorial, where we had to talk on bands. But then we had this perovskite material in the hexagonal phase that we needed to look at. And I noticed I also got feedback from people who got involved in it. It's really large. The cell is large, like it's a huge cell. So it's something that some people could not do on their computer. As a matter of fact, I'm even running some of the calculations now. I've been super busy, but I had to somehow make out time between yesterday and today too. But I've not been able to complete it. Okay, I'm still doing convergence testing, but the bulk of it has been done. So let's get feedback. How has it been for everyone that is engaged, and how do you think we can get better so that we don't come here? And also, I also want everyone to know that nobody is being paid, as in we don't receive a dime, like not 1 naira. We have not applied for funding. The last time we had Dr. Mayali from Kenya, we didn't give him anything. It's not right, actually. Yes. So we are hoping that we can make it better and we can see how we can apply for funds. But then we also need to measure the impact. If it has been impactful, then it's something we can, squeeze out a proposal and say, okay, let's see if we can get some funds, for this purpose. So that's the reason why we want to have this kind of engagement, this kind of evaluation. But I really have to mention here, because sometimes when people see us come online, it's like we are being paid. No. So nobody has received anything. This is just bettered from, the place of passion, um, from Professor Olayinka, and also because he is my mentor and he can easily push me, say, Rita, go here, and I will just obey, even if I always say, it's not always convenient, but when he's saying do this, I don't have a choice. I just have to obey. So please, let's hear from people. If you're comfortable, um you can um you can share your video too. So yes, if you're comfortable like sharing your video, you can also do that. I think maybe before we send this to YouTube or whatever, we would do a bit of editing and take out all these informal talks. And then, yes, we will not share this on YouTube, okay? We would edit it by God's grace and take out the informal talks and just project the highlight for today's webinar. So I'm hoping to get some feedback. Yes. Anyone? Prof, I know you're here. Oh. Prof, can we start with Prof? Maybe Prof will encourage others to, to talk. Yes, thank you, Ma. Mrs. Titilayo Akonvi says, we thank the organizers for sacrificing, for the sacrifice you're making. Thank you so much. It's also fulfilling, okay? It's also, for me, it's fulfilling because I think I'm a born teacher. Like, I enjoy teaching. And I don't just teach at the higher level. I teach all kinds, young children, secondary school, I just teach. Yes, it doesn't, I don't get tired doing it. And of course, we know that the educational sector in Nigeria is not exactly well paid. And a number of people that are interested in education are drifting away from education. But I think I'm comfortable in this space. I pray God blesses me, but I enjoy, yeah. So for me, it's a joy to be able to share my knowledge. And also because I feel that so much has been done on me, like I've gotten some kind of investment from people that I didn't even have any association with. And what more can I do? Give back. Yes. They are investing on a few people so that those ones can actually multiply the knowledge to others. Like Assessma is a forum that not everybody will be able to attend because the number of people that apply for assessment every 2 years, whenever they're having the school, it's always huge. And then not everybody, even for me, I couldn't attend the first 10 assessment. It was after the first decade that I was able to attend. And I'd been applying from like since the first time I got to know about assessment. Maybe I was doing something wrong, I don't know. But yeah, so not everybody may have the opportunity to attend such forums. So if by any chance you can attend, it's only wonderful. I think it's fulfilling to share the knowledge to as many as you can because there's a lot of money that is spent on each participant for 2 weeks. And yes, thank you for the message. Mr. Tobore or Dr. Tobore or Professor Tobore. Yes, good morning, everyone, and to the conveners of this webinar. It's been inspiring. I'm looking forward to the hands-on section today. Yes, we'll have a bit of it. I am hoping it will harmonize the knowledge of, yes, yes, yes. So we are not trying, like today, we are not going to be doing something completely out of the box. We really want to use the little things and add a few more tools, that we already know so that we can have like a robust knowledge from, previous talks. And yes, at least the basics. If after going through all these webinars, we should be able to have like basics, electronics band structure and density of states, to characterize the material. You should be able, for everyone who has attended this webinar, should be able to do it comfortably. Comfortably, okay? So yes. Yes, is there any other person that wants to say something? You can unmute now. You can talk. Unmute yourself. Yes, you can unmute yourself. Yes, you can. Yes, sir. Dr. Daniel, please go ahead.
Okay. Okay. Good morning, Ma. Good morning, everyone.
Morning.
Please, can you hear me?
Yes,
Yes,
we
we
can.
can.
Okay. I'm sorry first for joining the meeting late. I've been having network issue today. So I just want to ask a question in regards to what we've been practicing. I don't know if this is like a session of a feedback you're doing. You know, I joined late so that I won't say the wrong thing, the right thing at the wrong time.
Yeah, so it's a feedback, and
Hello,
then
ma.
yes, it's a feedback, and then we are going to harmonize
Okay,
everything that we have learned, like on hands-on, using
okay.
experience, like doing some practical stuff from the perovskite that we worked on, like we referred to in the last time. So it's feedback and hands-on. Yes.
Okay, ma. Good. Okay, so what I've been able to this current meeting is to go through again on the basics of the Linux, that's the Linux commands. Then I look at the practical examples from the assessment,
Assessment. Yes.
assessment folder, and a few from the previous one that's the one that has 10 days. So
Okay.
like the one of assessment, I discovered, like, I don't know if there's a problem with the command. If you want to view the molecule, which is the initial stage, it won't open. So, but except if I copy the file to the previous one, that's the one we had that was for 10 days, then it will open there. So, so that's one. Then another thing I wanted to ask is, running a new sample now, like this one that we have in assignment now,
Yes.
like from after we downloaded a CI file, I have the file, we have the studio potential. So I wanted to ask that, do we need to copy some other files from the previous place, or do we need to generate some other files that will be able to give us access to the Crisden visualization platform and maybe the other plotting like GenuPlot and that? Or are they already installed with the Quantum Expresso, the Quantum Mobile machine, the machine we are working with? So that's my second question. Then I think for me, I had to go back again to some of the basics of solid state, then some other theoretical basics on Quantum Expresso to be able to understand the basis of the functionals, and also the hybrid functionals, the basis of choice of a key point, which I think understanding the solid state perspective of it and the theory has really helped me now to appreciate more when you are calling some of the terminology, the pseudo potential and that. So that's what I did. So, but I think I need to respond to those two first things that I mentioned, that if we want to run a sample now, are there specific file we need to copy to the folder where we will now open our terminal to run those analyses?
Okay. Yes. So thank you very much for this feedback. It's really nice. Now for the first one, the assessment quantum mobile, for every school, the organizers usually set up a quantum mobile that would suit whatever exercise they want to do. So assessment, yeah, it was designed by Yuri. Yuri is one of the developers of, in fact, I think he originated HP.X. That was what he did in his PhD work, and it was present as assessment. So the reason why assessment is good, the quantum mobile from assessment is good, is because it can, Prof, welcome, sir. Good morning, Prof. Prof. Salenka is here. Good morning,
Good
sir.
morning, Prof. Mhm.
Yeah, yeah, I think he would unmute himself and say something while it's ongoing. So Yuri and some other people were able to like configure or arrange the quantum mobile such that it will be able to do HP.
Dr. Rita, we can't hear you.
Prof is, yeah, Prof is doing some stuff with it. Okay, so so that we could be able to do HP.X. HP.X is the UBAD parameter code. HP UBAD parameter. So with that package, you can actually calculate for the U values and then use it in your calculations. What is the HP parameter for? Now, some materials, they pose as metals, but in real state, they are not metals. If you look at the band, there's always a gap. Now, because there is this self-interaction that has not been taken care of using our normal pseudo potential. Okay, but with HP.X, there's a correction. No, HP.X is not the only part to, it's not the only, your name has been changed. Okay, so someone is changing my name. Okay, now, HP.X, I'm sorry for that. Okay, so HP.X takes care of that self interactions, and which is excellent. Now, the compilation is like what they use the libxr for its compilation. If you do it on a, just the conventional quantum espresso, it may not work because of the kind of compilation. But I think for the higher versions of quantum espresso, I've not tried it, then maybe it would work. I have 7.2 that I compiled on my own, and HP.X doesn't work on it. Yeah, because of the mode of the compilation. So for that quantum mobile, I think it works with, Prof already mentioned, so you do Conda activate those visualization. If you want to open, if you want to visualize something, you need to like use Conda to activate that visualization environment. I think so. Yes. So I've been using 20 points, I think 20.03, and it's okay for me. I've not had any trouble. So I don't migrate, to the new all of a sudden. There are always changes, okay? And it's not easy moving your files from one quantum espresso package to another. So I just try to work. This one is stable until I have a need for a higher version. That's when I would change. I was using something lower before, then I changed. So I don't see why I should change that, but I know what the changes in some of these newer versions of this quantum mobile. So you have to like activate this visualization. You have to activate even the quantum espresso environment to use them. Yes, I think so. That's why it doesn't seem to be working. Then the second one about harmonizing, yeah, okay, getting files, files, if we can get files from that assessment folder. No, you don't really need, and they can actually get the main details of this bands. And I'm also going to be teaching you how you can use HPC on the terminal. Yes, so there are many things you can't do on your system because when you have large system, you need to like move them to a high performing computing facility if you have access to it, and run it there. So personally, I've now been running stuff on my computer. I only do very mild stuff on my computer because of testing. But if I really want to do any major stuff, I do it on this HPC facility. Now, not everybody has access. In fact, having access to HPC is not easy because the way it's sounding, it's not easy. Yes, because then, and also, even if I have access, I don't use it anyhow because I give account of the world time that I use, the computer time I use on this facility. So you can't be using it and not productive. If you are not productive, it means that they will take you off that platform. You are using the world time or the computer time, and then you don't have papers to show. It's always it's like putting one on the negative end. It's better you don't even use it. So I use it when I know that I have something to do and I really need to get this target done. So you always have to make account for it. So is there any other thing? Yes, and good job, sir, for solid state and everything about this material science is solid states and quantum mechanics. Yes, so when you do this, you know what it does is that it sharpens your knowledge, that things that you've already dumped. You find out that little things, you find out where they are finding place, variational principles, Schrödinger equations, the eigenvalues. And if you teach in the university, you find out that when you are teaching these courses, it's so easy for you to relate it with your student because you are practically involved in it. Yes. So that's the beautiful thing about working with these schools. Any other contributions?
Okay, yeah, thank you, Ma. My second this thing is like moving files. The last meeting, we raised concern about how to download, maybe when you download file from, maybe how to move file from your system to the Quantum Mobile. So I discovered that I can move file from my desktop or any location on my system. I'll just copy and paste it on the Quantum Mobile, but I cannot move from the Quantum Mobile back to my system, except if I send the thing to my email, then download it from the other side. So I don't know if there is a better option.
Yes. No, there's no option. Quantum Mobile is a solo environment. Like, it's just independent. So anything you want to do with Quantum Mobile, you must give permission to share with your local computer.
Okay.
So what I usually do is that when I share a folder with downloads, I share a folder with documents, and then I share a folder with desktop with Quantum Mobile. So when I go to my Windows, in my Windows, in the desktop, I have a folder that is called shared download, shared desktop. In my download folder, I have shared download, and then in my document, I have shared documents. So those three folders are the ones I share with Quantum Mobile. So anything I do, and I save it on those three folders or those directories, I can see it on Windows. I don't have to send to my mail. So Quantum Mobile is like that. You can't even put your flash and want to get something from Quantum Mobile. If you share it with your local computer, like like I've said, if you share it there, then you can easily get it from any of those folders or those directory.
Okay.
Okay,
Then
I see.
lastly, okay,
Is there any other
fine.
one?
Okay.
Go ahead, please. Go ahead,
Okay.
please.
Then the last one,
Okay, certificate of participation.
it's certificate people. We need the knowledge
Go
first.
ahead, I can hear you.
Okay, ma.
Oh my God, we need it. We all need it too, actually. But the
Okay.
certificate to be given based on if you have completed your assignment. If you do your assignment, I get it correctly. Okay, go ahead, sir.
Okay, ma. Then the last time I asked a question about when you run the SCF calculation, that I was trying to give an example of like in OCA, you will see Hure, you see the point of convergence. Yeah, so when I try to practice, during my practice, I observed that when you run the SCF calculation, under the total energy, you will find a convergence point. So which I think, that day I was trying to say that it's like the first point of the calculation is to have a state of geometry optimization, where you optimize the geometry before you can then apply it to any other calculation. So it's like maybe from a relaxed state, you do either the SCF or NSCF before you can find things like the band structure, density of state, before you can visualize the bands and other calculation, magnetic property as the case may be. So that was what I was able to identify. Yes. Then the last one is I also asked about how to understand the theory level, because not all functionals that you can use for any system, any periodic system, like even under the GGA, there are hybrid functionals. So there are cases where you can use the LDA, then under the GGA like PBE. So those are hybrid functional that you can't just use with LDA. So I think from your experience also, I don't know if you could tell us under what condition really can the hybrid functionals fit in? Because like I was talking about when you're dealing with molecules that are involved in charge transfer, sometimes you look at the charge transfer distance, You'll be able to know the kind of functional to use. Like a molecule now, like the P3LYP, I think is a common functional for geometry optimization. But when you are dealing with long-range distance, charge transfer distance, then you may be considering some hybrid functionals like CAMP, B3LIB, and as the case may be. So I don't know if you have something to say about this. Thank you.
Thank you, sir. Thank you so much. You are very deep in your research. Oh. Me, I've not even gotten to what you do. I don't use more of these hybrid functionals. But what I can tell you is that, for each of these of them, they usually have forums. Now, they will tell you that they have tested with PBE, they have tested with so-so, they have tested with that, and they'll tell you which one works. Yes, they always tell you. Like when you do optical calculations with EP.X, you use non-conserving, okay? I may not be able to give you reason why. That's something that is not ultra soft or something. It is all that are close to experiment. They have everything. They have reasons for using them for certain properties, and because of testing over time, when they do this, okay, this does not give results that are close to experiments with this, and okay, like U and have interaction of electrons that they come about, and strong correlated materials that they come about, doing something that has to do with you or something. So how do we overcome this? So all of this, before you dive into but I don't think you should start with something complex. There are so many little things that we have not even unearthed at all. But if that is what you want to do, you have to pay attention to the code that is in Quantum Expresso and take a look at the information from the developers, okay? And then you'll be able to adapt it to your research. You may not be able to do like changing so many things, but look at those that developed. So look at the developer's notes on each of these packages, and you can tell which pseudo potential would work for it and which pseudo potential is not compatible. So these are some of the informations you can. If you are using, materials, strongly correlated materials, with very high, maybe atomic number, you may also want to check, okay, how does the U parameter hybrid functionals affect? And you can even pick it up as a study. You pick a material and see the effect of these functionals. I'm already giving you insight on, how some papers that you can publish. So you can pick a very simple material and see how the effect of these functionals, the effect of this function on this material and compare with the experiments. That's already a paper. So the research is unending. Like, research doesn't have like, this is a limit, this is where it should stop. And if you do this, I'm telling you, you are going to, I think your citation is going to be more on that paper, because you are giving reference to other people to tell them that if I use this pseudo potential, this is the kind of result I'm expected compared to experiments. So you are like, it's like doing a review paper. So many people making reference because you have practically highlighted the pros and the cons and the disadvantages of, or the advantages of using certain pseudo potentials. So I think that on its own, it's another line of research that you can do. Yes. So did I answer the question, sir?
Yes, ma. Thank you, ma.
Thank you so much. So yes, sir. Prof.
Hello, Dr. Rita.
Yes,
Thanks
sir.
for the explanations here and there, and they are helpful. But however, my network cut off. At the initial stage of this program, you were discussing about finances as a debt. So I think that was when my network messed up. So I couldn't get that. By the time I rejoined, I couldn't pick it up. That's number one. So will you respond to that first?
Okay. I was going to say to everyone openly that nobody gets a dime for doing this.
Okay.
This is just bettered in Prof's heart to share. And Prof is my mentor. He can say, Rita, do this, and I will just follow. I don't argue. Okay. I was saying that it's not convenient. It's not even convenient for right now. He's on transit, but he's here to ensure that this webinar holds. It's also not convenient for me. Yes, it's not convenient for me.
Definitely.
Yes, I'm on a research visit. Yeah, I'm on a research visit to Ghana. I came in. I've not settled in Ghana like now. You know, I'm already in a webinar, and I have a research target. I have not even done that. I am in this webinar, so it's not convenient for anybody. But we just have to do it. Yes, and in the place of fulfillment. And the truth is that whether we like it or not, we see it in our teaching lives. If you sow a seed, you expect to reap, in accordance with that seed. If you are sowing, from a heart of, okay, I want somebody to do well, to do much better, you will find out that God somehow has a way of, repaying you back. So, but we are hoping that if we can put this together. Prof, you are here now, you are a professor. Me, I'm still a small lecturer.
I know. Small indeed.
We can,
small but mighty.
Yes. No, I'm still small. We can package these things and apply for funds. We will get it.
Surely.
Yes.
Surely.
So, but then we need to.
I think one of the things we could do is basically, these are just my own suggestions. One, if the program requires that we maybe our widows might one way or the other, whatever we can contribute to keep the program sustained and moving for now, we can. But I am pretty sure that down the line, it will definitely gain ground and have its footing. So one of the things we can do is this TED Fund stuff. We could package what we are doing now. Since we have a sustained program, we could package, write a proposal. Maybe this year's zone is gone. I think we can plan against next year and possibly start putting down certain things now before the call for proposal for next year comes. So we put it up, and since it across universities in the country, and I think I'm pretty sure by the time we put all these things together, and I hope all these things are being recorded.
Yes.
So these are some of the things we could package, and we can surely put that together and push to TED Fund. But we need to start planning now so that we have a vision of what is required for us to really do this thing. In fact, in our proposal, we could even add the issue of HPC, having our own HPC, so that while we are having the training, we can really have proper hands-on and whatever. And we can as well ask people from outside the country to even come in to assist us in training and whatever. So these are some of the things we can put together. It crosses across universities, and so I think with that we can. But for now, whatever widows might we have, if there's need for fund, let's know. So whatever widows might we have, we will just put it up and we sustain the program. But down the line, let's plan against next year's proposal. Because I saw my dean post, because I am also not in the country now. So, but I saw my dean posted yesterday that people should go to the TED Fund website. The PIs should go and check whether they've been shortlisted or whatever. So I think it's gone. But let's plan against that of next year, so that so we can speak later, maybe with Professor Lainka.
Yes.
See how we can package something to sustain that.
Yes,
that's number one. The number two is I observed that when you have access to HPC, accessing the HPC differs from one HPC to another HPC.
Yes.
Because I currently have access to one, but I asked Dr. Adegboyega, one of my students who just had this Viva, to load in certain codes, but we've been having issues getting it done. So I really don't know. That's what I want to verify. So how do we surmount that problem and how do we go about that?
Okay, thank you, Prof. Thank you so much, Joe. You don't know what it means to have a relationship with a prof. I know that
Okay.
yourself and Dr. Professor Lainka will be able to put this together. We've had that, I've had that conversation with him. We've talked about it. Yeah, because do you know why it's important? So that we can also invite other people. You can't
Yes.
invite like Dr. Mayali from Kenya. We did not give him anything. Usually would have given him, no matter how, would have given him something. So if we really want to get people from outside, we want to leverage on our relationship with people who would gladly come in to actually speak, we need to give them a token. That's the reason
Yes.
for these funds. Right now, for us, for for Prof. Olayinka and me, we are okay. Like, we are okay doing this. It's not a problem. But if we, at a point, we need to get like refreshed. Even me too, I also need to get refreshed, getting other people to talk and then, and everything. So we would need that. Yes, of course, we'll put all these things in a beautiful proposal, and we would send it not only to TED Fund, there are other, funding agencies that we can use. Then HPC differs from one, system to another. Let me just give you insights. My university is also planning to set up our HPC, but of course, it's going
Wow.
to be commercial based.
It will be commercial based.
Yes.
Hey,
So
hey,
to be
hey.
commercial that, because you are going to be funding, you are going to be, it has to be connected to light 24/7. Yes, so it's not
But you are
easy
richer
doing
than
that.
the richest
Yes,
now.
especially in,
Why do you want to
I'm not the
commercialize?
owner, I'm not the owner of the university. I'm just giving insights that
I know, I know.
very soon we would have it. We would have such in
Okay.
Nigeria. And we don't even need very big resources to have, a small cluster. You can actually build a small cluster. Professor Dr. Molulu was able to do that in Rwanda. Of course, that's a bit big, but we can also like get resources, but it takes a bit of money to actually set it up
Yes,
anyway.
I know they have one in
Mhm.
UI, but I don't think it's functional as a result of energy crisis.
Yes.
So
So
at least since it has been installed, it has not been functional.
yes, so
So
energy is a critical stuff. But
it is.
right in my own university, we have
No, the same
light.
thing with my university. In Unilag is the same thing. We don't have issue with the energy.
Okay. So,
It's just that the
but
bill is high. The bill is
oh
high.
yes, it
So we
is. It
pay
is.
$500 million monthly.
Wow. Wow. We are generating our own power. So you know what
You
it
are
means.
richer than the richest.
It's not richer than the richest, but it's for they want life to be comfortable for everybody so that we can give it our best to teaching. So
Yeah,
that's it.
definitely.
Now, this HPC facility differs from one computer to another. You cannot just go ahead to install if you don't have admin rights. I think one of the things I'm going to learn on this my visit, because I'll be working with one of the PIs of CHPC, and then I will
No, the thing
use,
is cracking. I couldn't hear you there.
to ask questions, like how to actually. Okay, I said one of the things I'm going to learn from this my visit is how to actually compile your own codes in any HPC. I'm going to learn it because the PI I'm working with, my host here is a PI with CHPC. So I plan to learn it in along all the learning I'm going to be learning. Okay. So, but majorly for most HPC facilities, you need admin rights. And if you don't have, you can always write to the help desk and tell them to compile it for you. They will do it. Yeah. And if of course many people are requesting for it, they will do it. Like the thermal PW was not formally compiled in CHPC, but somebody from FUNAB made requests. I know the person, and I think other people now backed up that request, and they were able to compile it on one of the versions of Condom Expresso. Not all the version has thermal PW in CHPC. So HPC is very, yes, and there are also some commercial HPC. Someone is asking, yes, I think Professor Lainka has information about IX something. They are also commercial where you have to pay. But the truth is, how much do we earn that we want to
That's
start
it.
paying for
That's
all
it.
these
I'm paying
things?
in dollars.
Yes, how much do we earn? If you're in Nigeria, how much do you earn? That you now want to remove from that salary to start paying for HPC. God will help us, but we just have to look for ways to pass this order. Like in at UI, tag, they gave us access. So if we really want this thing for a project, and in order for us to also apply for this funds, I think we should come up with some papers, 1, 2, 3 papers to back it up, that we are working, we are only limited in this sense. Okay,
Yes.
so we have to do our own part. If we have 2 or 3 papers submitted in Q3, let's even say Q3, Q2, maybe 3 Q2 papers. That's something, we put it that, see, we are doing much, we are doing a little with nothing. If you give us more, we will do so much more. So those are the things. It's not even, we need to work. That's it. We need to work and get some things done. Yes, Dr. Daniel, please.
Thank you.
Yes, sir. Thank you, Prof.
Thank you, Prof, for the input. I just want to add something, or a suggestion, as a follow-up to what Prof just discussed, that if you can write a position paper, also addressing it either to the Committee of Vice Chancellors or even to the TED Fund directly, without having to wait for the TED Fund NRF alone. Because the need for HPC is not even only for people in physics, chemistry, they are doing it. And now that TED Fund brought out a letter that from January, they will not be sending people to abroad again for both masters and PhD sponsorship. I think, yes, because people who go don't come back.
Yes, they don't come back, they japa.
Yes. So we can also
Hey!
give reference to that we really need this for
Yes.
researchers. Because of, like we're saying, the money they're even paying us is not even sufficient to keep you as a lecturer fully. Don't talk of
At
doing
all.
research.
Yes.
Floor
So thank you so
competition,
much. My
So
school.
then
Okay, go ahead, sir.
Okay, so many people are moving now to computational, even those in bioinformatics, even the what they call it, those in biological sciences, they are doing some computational now.
Yes, even
There are
biological,
certain
even
things
those in
Yes.
computer
molecular,
science.
Yes.
Even those
yes,
in
there are
computer
certain things in
science.
molecular
Yes.
docking now that
Yeah.
you cannot run it with the ordinary discovery system.
Yes.
You have to run it on
Molecular
HPC.
docking and the rest.
Yes, so
Yes.
you have to do that. Then, lastly, the TED Fund NRF that I understand, well, Prof, we have more experience than I do, because this current one, I also applied and my concept note was accepted, which I'm trying to prepare for the proposal now. So, but I think it's more, I think the consideration is more researches that are national based. I don't know if it covers this, except if we design a research that covers a local need, then now pointing out the need for us to have an HPC to be able to run it, then with the interdisciplinary nature and inter-institutional base that we are made up of in this team, that could be a strong point. But I won't want us to only wait for that period. If we can have a position paper developed, either when we try to work on getting 1 or 2 papers as a backup, like you said, they start to explore other means, like the Committee of Vice Chancellors, then also writing directly to the head of TED Fund. Because it seems that there is a little reformation going on in TED Fund now. So we can leverage on that and put through our application. Thank you, please.
Wow, thank you so much.
Thank you, Dr. Daniel. I think with the issue of TED Fund NRF, I have one running with some colleagues in my university currently. We are working on lithium. So, but it cuts across. We have people from MetaMath, we have people from chemistry, we have people from physics, so it cuts across. So majorly for the TED Fund, because ours, what we are trying to say now, it's even more better. We have a forum where we meet as theoreticians, and these are things we do. But the major thing is, like my own research, majorly is tailored towards energy. So if I'm picking up any material, I make sure it can be used for solar cell majorly. That's what we do. So, and energy is a big problem in the country now. So if some of those things, if we can put up some of those things appropriately, back it up with some of the research work we are doing, not just saying it can do this, it can do that, but at least we'll have a way, like when we do that, we use something like SLME to actually see the efficiency. At times we use CAS, or we can use any of those software to compute them, to look at what the efficiency will look like, we optimize and so on and so forth. Majorly, that's what we do. So if you can back it up with what it can do, our research, and I think it's going to fly. Though we can also try the route of going through the committee of vice chancellors, but I don't know how vibrant they are. But TEDFund itself has its own committee and whatever. And I think aside from this forum that we hold maybe once a month, maybe some of us can just form some group, those that are consistent and persistent, because that is what research requires. You have to be consistent, you have to be persistent. Those of us that are forthcoming, maybe about 5 to 6, we can come together from the various universities, because that is what they want to look at. This thing is cutting across not just a single university, but cutting across almost the entire nation. So I think basically it will fly once we are able to package ourselves. And we might even see some people to help us look at it. Because I have somebody like the director of our CITS, he has a lot of grants and is very good when it comes to grant writing. So maybe by the time we finish, we can push it to him to assist us to look at it. It's also part of the one we are running, the NRF currently, is the MetaMath. But when it comes to grant writing, he's very good at that. So we could package it and allow people to check it for us so that we can cross the I's and dot the T's for it to be pushed. But we must start planning from now so that as soon as the NRF stuff is out, then we can push the concept stuff. So, and we'll see what God has for us.
Thank you, Prof. You're already a part of that committee.
Okay, no problem. No problem.
So thank you so much. I think it would fly. I think it would fly. Yes.
It will fly.
Just need to,
I'm very sure of that. And there are ways by which we can manage. The only thing is that if we write for APC, so we need to get all those things done. I know they already have a mathematical center in Abuja, though not functional. That's the major problem I have.
I don't know if it's
not
also
functional. Because basically they are supposed to have something like HPC, but what you see them do is that they train teachers from secondary school. We've lost it. I'm telling you.
No, but I think they also have connections with the US and many places.
Maybe now, maybe now, as of 2009-10, because I was in Chesco then, and you know the share boundary. I was in Chesco running my research then, but even Chesco now is gone. I don't know.
God help us. God help us. God
so
help
us. It was at Chesco I met with Professor Lanyinka. We were all there together. We were there together in Chesco, 2019.
Okay, so someone asks about Thermo PW. You know, let me tell you, like I also mentioned with Prof, Thermo PW is excellent. But if you are learning how to do stuff with density functional theory and you don't want to be a runner of codes, but you want to have an understanding and also maybe at some point contribute to these codes, Thermo is not the code you should use. It's like a cheat code. I know a number of people, yes, please, I'm not saying that you should, align with what I'm saying, disagree with it, but I just have a principle as a person, because it does everything in the background. When you do the elastic constant, there are two methods, the energy method, the stress strain method. If you do it, you will not even know one thing. You will just have results. But if you already have understanding of what these methods are, you can use Thermo because you know how to tweak some of these parameters to suit your. So yes, I always do not encourage people that are learning how to do, computational stuff to start with thermal. It is good, but you will not learn anything. Is the truth. Because everything you need for thermal is just an SCF file and then a thermal control file, and maybe if it's a pH, if it has to do with lattice dynamics, you need another file, and it's there. And all this documentation are available on the Thermal PW website. They have examples. Just choose this example that looks like what you want to do. Copy the thermal control file just the way it is. Then you set up your SCF file, understanding the structure. You have done your relaxation, you have done everything, and just put it to thermal, and it will just run it for you. Yes, if you understand the basics of quantum espresso or DFT, then you can go ahead and start using thermal. But if you are just learning, I don't encourage, because you will not learn. You'll be a runner of code without understanding. And we don't want to be developing, we don't want to groom people that are just running codes and don't have any theoretical knowledge. When you say eigen value now, you say the band structure, are they eigen value? Are they, no, please. We want to groom people that understand what the outcome of these theories, yes, from our fundamental quantum mechanics and then solid state physics. So yeah, but then we'll share your screen to see. I don't really use thermal, like I said, but I know how to use it, but I don't really use it. Like, why do I want to use it if I can actually compute it on my own without using thermal? So yes, I'll give you time to share your screen, and then we'll do it. So I also wish papers be published at the end of, yes, like we said, this and we don't have to send them to very, maybe high impact journals. We can leverage on conferences. Conferences that publish their work in Scopus Index journals. We can use them, okay? Those works will always be available to anybody that, and it doesn't have to be complex. So these are the ideas. You don't wait until something big happens before you begin to do stuff. Every little step, as you go in life, men are of different sizes, and life is in phases. Just every little phase, try to do something, package it, and send it. It may not be a Q1, you are targeting a Q1, but it can be from a conference paper that is Scopus in, that has a Scopus index, then you move on. So yes, we will do it. We will do it. It's not easy getting papers, I'm telling you the truth, and we also need committed people to do this. So I'm going to stop sharing, and yes, go ahead,
please,
please.
may I come in with respect to
Yes, Prof.
publication? I have read that on the chat stuff as well. But what I may suggest is maybe this coming year, maybe I would suggest maybe we design a research that will encompass all of us working on. Maybe we can divide ourselves into groups, and those research assignments are given. It could be published. It's not necessary, because publishing nowadays is erratic in nature now, especially in the Elsevier, the Springer, or whatnot. But we also have some good journals, like this Nigerian Society for Physical Sciences, NSPS, is Q3.
Yeah.
International is Q3. So we can do some stuff and we push it there. So maybe we are seeing some committed members, maybe just about 20. We could divide ourselves into about 5 groups, design some basic research, and we all look at it together. Then we go ahead with it. We give ourselves some timeline, maybe to compute them, maybe within a month or two. Then we try to see what the results look like holistically together. Then manuscripts are written and vetted, and it can be pushed. So these are some of the things that we could add to whatever proposal we are writing. So it will really go a long way that there's proper hands-on training and whatever that is being done within the forum or the group. So thank you.
Yeah. Thank you, Prof. Prof, you are very experienced with this now. When you have collaborations, some people just want to be sleeping while others are working. That's not a good collaboration.
It is not.
if we have people that are ready to work, we just share the work. You do this, you
Yes.
do, you do this, you do this.
You do this, you do
Everybody
that.
in 1 month come, of course, everyone has been groomed through
So,
all these little things.
so that even
It will be fast.
aside from the monthly meetings,
Yes.
they'll be meeting within themselves
Yes. So we'll
and
be
try
able
to
to
solve the problem.
we'll be able to do that. So, but if you leave it to only Professor Olopade now to do it, or Professor like that, they are professors busy still doing admin work, examining students not even in their department in other universities, it is not going to work. I'm telling you the truth. And then for some of us young lecturers, in fact we have a lot of commitment to. Like my university, is work is work. It's not we are not playing. Work
I know
is
it's
work.
private.
So that's it. So you can't be doing stuff for people, and then people are not contributing. So if we are once we are ready, I know a few people in this group that are already shown interest. They have started, and like they started with what we are going to do now, we are going to the hands-on now, setting up a script to do convergence testing for ECOT. When I got such data, I just edited and I said, okay, you try to run it. But I know that these things are really large. You cannot run them on your computer. So let's move on now to the tutorials on that perovskite, and then we wrap up there. Okay, is this fine with everyone?
Yes, that's cesium copper chloride.
Yes, yes. So I was already doing it. This is actually on CHPC. So let me open a new terminal. Um
Dr. Rita, if I may ask, with the Q
Yes, sir.
mobile, because it was the last meeting we had that I knew of something of such.
Okay, sir.
So I installed it then, though I had to upgrade my PC to Windows 11. So, but
Okay.
I will do the reinstallation. If you have the Q mobile, that means I don't need to have partition in having the quantum
No,
expressor as dual booting again.
no. Like this meeting now, the Zoom meeting is on Windows, and I've switched to. I just minimized to
Yes,
Ubuntu.
yes. So it's
So
better.
yes,
Okay. Okay.
yes. And then the issues of compilations are not there. You almost all the libraries that you will need, not for only Quantum Expresso. Let's say you want to even do transport properties with Bootstrap, you want to
Okay.
get, the libraries are already available. You
They
won't
are
be stuck.
available there.
Yes,
Okay.
yes. So the moment you
So,
start compiling for any other code, you just find that it's moving smoothly because all the libraries are almost available.
okay. Okay. So, which means I can remove the partitioning.
Yes, you don't need the partitioning again.
Okay.
Yes, you don't need
Okay.
the partitioning again.
Okay. Okay.
So
Thanks for that.
this is my own quantum mobile. Well, welcome, sir. And it's version 20.03.1. It may be different with yours, okay? But the core of the subject, how to use it for this, is the same. The only thing that is different is launching the Quantum Expresso environment, launching visualization environment in the newer versions. Here is just working like you don't have to use Conda to activate any environment. It's just there. So now this is uh where this is a shared folder. Someone asks about, Dr. Thomas asks about, this is a shared directory with my Windows shared. So I have the projects, and then this is the compound we spoke about. And the paper I shared, it was even Professor Lanyika that, you know, gave me, this is the what I shared with everybody on that. Yes. So CSCUCL. Now, you may want to read everything, but we don't want to read everything. We just want to do like the band structure for this calculation, for this compound. And last time, somebody was able to download, sorry, was able to like download the C file. So I'm going to teach based on how I do this. Okay. So when you have downloaded your C file should be something like this. This one I got it from COD. COD. If you go to COD, let me show you COD. So you can see, Prof. See, I'm navigating Windows and this together.
Yes, yes.
Yes, so I don't have to, yes, I can do my stuff. So let's go to COD. So to just have it, COD is one database like materials project. Well, me, I like this one. This one, you don't need any login. As you enter here, you are already into it. You search, and then you put the elements. What element does you want it to search for? So you have cesium, we have Cu, and then 3 elements, Cl, okay? So maximum of how many elements? 3. Minimum and maximum 3. So it shouldn't give us like compositions and everything. When I do this, I just send. It gives me, it's easier for me than sometimes, logging in through. So just look at any, I use both of them, but if I really want to do something quickly, I just use this one. So COD, I got that C5 from COD. Let me just, yes. So this is it. You can see the different compounds. So you just look for the formula. This one now, yeah, this one looks like what we are looking at, Cu, Cs, and Cl3. Yes, in this space group number, and this space group number is hexagonal. So you might want to look at this journal, or you just download the CIF. You can just download the CIF directly from here and save. Okay, so I'm not going to save it because I have it on but this is where I got it. Now, this is how it looked like. You can see that this file is available in crystallography open database COD. This is where I got it. So what I usually do is, because these C files and these codes, they are sensitive to symmetries. I usually go and check the symmetry, in what we call find sim. There's let me open this site, find sim. So I'm just going to do it like it's me that is just working. So I learned this by taking courses. They didn't fall upon me. I learned it by taking courses. There's this course taught by Professor Stefan in Ghent University. That course is very good. I did it in 2017, and I still make reference to it. If you look at the group, the WhatsApp group, I shared a document. I downloaded it from this morning from there. So what it does is that you go and choose the file. You choose the file, that C file that you downloaded from, from COD. I think this is it. We want with number. This is it, and upload it here. So what it does, this website is to check the symmetry. If the symmetry is exactly what is going to be useful in your DFT code, because if the symmetry doesn't look good with your DFT code, you may have issues. So now with find sim, you can also get a C file. So from here, you see this point, you copy it down to this point where you have end of C file. Just copy it and then save it. So let's say I already copy it. If you notice carefully, I have a file I call find sim. This is that thing I copied. So this is that thing I copied here. So it's the same symmetry. But now the symmetry has been checked such that if I put it in any DFT ab initio code, VAPS, quantum Expresso, I will not have issues as regarding symmetry and the code understanding the symmetry of the material I'm working with. That's the reason why I do that. Okay. Now, having done that, you now want to, you now want to convert to your quantum Expresso input file. So you can do it with materials cloud. You can do it with C2S. So let me do with Sift2Sell. Sift2Sell is also one of the tools that are available in Quantum Mobile. So I'll do Sift2Sell. I hope I remember the commands. Find theme, then I do -P, Quantum Expresso, output, then I put a name. Let me just put C2S.in. This would give me the primitive cell. So if I open that file, this is a Quantum Expresso input file in the primitive cell nature. Now, but sometimes some compounds, you can even see from this cell, the cell parameter, that this looks like hexagonal, because we already know that for the hexagonal structure, the vector, pointing to each of these that defines the structure, you have 1, 0, 0, you have -1/2. This is solid state now, over 2. This defines the vector, lattice vectors. So you have 0, 0, then C/A, the length of the cell. So if you look at this is 1, 0, 0. Look at this line. It's already almost like it. Of course, maybe not specifically stated that way. Then you have -1/3. √3/2 is 0.88. So I already know, yeah, that this is actually hexagonal. I know that this is hexagonal. So let me take up all these writings. Now, so now we know that we've gotten this. So I now need to, like, so you can do this with Sift2Sell, then you can also do this with so with how many input? Let's just do both of them together. We have 30. Number of atoms is 30. So let's go to materials clouds and do the same thing like we have practiced. So materials clouds, not projects. So work and tools. So with this materials cloud, you see you have a Quantum Expresso input generator, and then you have seek path. So if the K point or the K parts in the brown line zone, when you want to do the bound structure, you will get it from here. So we do Quantum Expresso input generator and choose that file. So now for me, it's easy for me to go and choose, this file, because I'm sharing a directory with Quantum Mobile. That's why I can do it on my Windows comfortably. So if you don't share it, you won't be able to do it. So this is the input file, and then we say, okay, generate. So please share some folders with Quantum Mobile so that you can move things from Windows. I'm not sure why this is having this, but let's see. Okay. I think I should have I uploaded the input file from Sift2Sell. So let me change this and let me change this to Sift2Sell, as in a Sift file. So I go to, this is find theme to generate. The reason why it's complaining is because Sift2Sell does not give you some blocks, like your system block. It doesn't give you, so it's not exactly in the Quantum Expresso input format. It just gives you some information. You also need to edit it, such that it looks like your Quantum Expresso exact, something that you understand. So that's why it's complaining. I don't know why there is a bit of delay, but when it comes to internet, you expect anything. Maybe I should go back. Anyway, or I should just proceed. then we compare. So now, so this is the input file from, and this was developed by somebody, okay? It's somebody's work. Yes. T whatever person, was the one that, the name is here. Yes, he was the one that developed this. So he's famous for this. I've also interacted with him on ResearchGate when I was using this tool to generate surfaces. Yeah. So, and he responded, to my, when I spoke with him. So now, having done this, you want to do your convergence. So I go to converge, and then if I go to converge, I have 3 directories. One is ecot, one is ecot role and kpoint. Now, let me go to ecot. I've already started doing this, okay? But I did it on CHPC. So this is where I'm going to teach you how to move a file. How to move a file from local to, CHPC. So that's one of the takes from this discussion. So this is the script. If you go to the assessment, you would also see a similar script. You see a similar script, but of course, without all this information here, no, because these ones are related to CHPC. All of these from here down to this point, they are related to CHPC. If you want to run it on your own computer, just take out all these parts and just ensure you have the first line, the bash, and then you have this line, and then you are good. Okay, so this was done. Somebody started this, and I, edited it and then sent back to him. He was able to run for ecot 12 and 16 because of his computer. Okay, so now notice something about this input file. iBrav is equal to 0, seldom 1. I've changed some things. This is not exactly the way Steve2Cell gave it to me. Steve2Cell gave me A. So I can show you what Steve2Cell gave. Let me zoom in. So you can see what Steve2Cell. It says A. This is one way to, put your input file. So it's dynamic. There's no particular way to do this. Just make sure you understand what you are doing. If you are not sure, use Materials Cloud. I think eventually I use Materials Cloud, but I just know that I did it in a way that, of course, you can try. Just make sure you know what you are doing. Yes, so you can see that here, this is seldom 1. If you put seldom 1, the unit of seldom 1 is in atomic unit, in Bohr. Okay, so unlike what Steve2Cell gives you A, which is in Armstrong. So it depends on how you want to use it. You can change this to seldom 1. When you change this to seldom 1, you need to convert 7.2 in Armstrong to atomic units, and then just structure it in a good way. If you are not sure about which convention to do, stick with 1, seldom 1. Then when you have mastered it, you can play around it. So you can see somebody simplify. It will be different from yours, and you'll be like, are you sure we are doing the same thing? Yes, we are doing the same thing. I'm just interpreting my input file based on my, solid state knowledge. Okay, so now this input file, it's going to do a loop. It's going to change the value of ecot from 12 to 16 to 20 to 64. And the default value for ecot row, the charge density ecot row, the default value should be ecot WFC, that is the plane wave, times 4. So that's why I've included it in this script, that for every ecot, make sure you multiply the ecot by 4 and use it for that input file. I see a message. Let me see. Okay. Okay, all right. Someone is asking for a replay. All right, so for what this line means is that for every value of ECOT that I'm going to run, multiply it by 4 and use it in that calculation. If you are not sure about this scripting thing, do it one by one. That means you're going to have several input files, each of them ECOT 12, and the next one is going to be 12 times 4, that's ECOT row. The next one will be ECOT is 16, and the ECOT row will be 16 times 4. Now, notice also something that I've used K points that are not even. I've used 12 by 12 by 6 for this because it's hexagonal. It's actually longer on the y axis. So, but in reciprocal cell space, the dimension is half the real space. So you take something that is pretty large enough that that would give you good results, and then for this KZ, make sure you do like, it should not be at the same scale as what to see. Now, another thing is that if you have done this and you are not sure because of, okay, for whatever reason for the hexagonal crystal structure should look like, you can also convince yourself. Yes, because this is your starting point. You must convince yourself and tell yourself that I know what I am doing before you start. Don't start without convincing yourself. You will not get the right properties, or you'll be computing a wrong structure. Now, one way to convert to doing this is to using a tool in Quantum Expresso. So I'm going to open a new terminal. Let me also zoom in. It's called the cell to eyebrow, because this one is giving us in cell underscore parameters. But you want to know, if you know the eyebrow, you can easily go and match the eyebrow with what you have on the PW input description to tell, okay, this one is hexagonal, this one is FCC and everything. So where can you find this tool? I have on my system a space where I compile my own software. So I compiled 7.2 Quantum Expresso. This is not the one that came with my Quantum Mobile. I compiled this one in addition to that. Okay, so you can compile many if you want to. Now, if you go to the PW folder and the tools directory, you'll find some tools. All these tools, they are not here for fun. The developers know that at some point you will use them, okay? The one we want to use is the cell. So we want to convert this cell to eyebrow, so that if I choose not to structure in this cell underscore parameter, I don't want to use that block. I just want to use eyebrow is equal to maybe 3, 4, 5. I can do it the same material. So you click on it and you enter the lattice vector of the first line. So this is our first line. I'm just going to copy it and I'll put it here. Copy the lattice vector of the second line. So you do it line by line. So you are defining the lattice vector. Let's say you don't even know that it's hexagonal, but you want to convince yourself. So you can do this. And then it tells you to give you enter alert. That means the cell dimension 1. You see, it has given me a new structure of my input file with eyebrow equals to 40 with 4. So if I choose not to use cell underscore parameter, I can use eyebrow is equal to 4, celldim 1, and celldim 3. So if you don't know what these are, you can go to the input file, the Quantum Expresso input descriptor. Yes, this is available online everywhere. Just put PW input description or descriptor, whatever, it will give you. So check, which one is eyebrow 4? This is eyebrow 4. It's already telling you that it's hexagonal. So you have to convince yourself that this material is hexagonal. So after you have convinced yourself, you can now begin to do all those convergence testing. If you are not sure, don't proceed with convergence testing. So now we do this calculation, and I'm going to show how you can run it on HPC. Now I'm going to connect to HPC. I'm going to connect to the CHPC facility. Now, before I do this, because it's my computer, I've customized it in a way that I want it. And I've also learned from people. So me, I'm just a bundle of, learning from here, and there and all. So I worked one time with Professor Keresoli. He's also one of the contributors to Quantum Expresso. And he was the one that showed me this, okay? So that's where I'm showing you. Somebody showed me. Please show it to other people too, okay? Yeah, so that we can all make progress. Now, it says that you can customize, just like doing, if you know much about Linux, there's what we call aliases. So instead of, if you need to type something that is very long, yes, you don't need to type something long. You can do an alias. So it's almost like what I'm going to do. So if you go to this uh, directory in your home, you can create this file, which I call config. You can create a file config here. And what it does is that any HPC facility that you are connected to, you can do shortcuts of it. So now for CHPC, my host is CHPC. I call it CHPC. This is my username, Omamu Yowi. O and then Jolayemi. That's how CHPC. And this is the host name. Okay. So if you don't do this, what you can do is that, so let me also zoom in. If you already have access, you do your username, Ojolayemi, at then the host name. So I'm just going to copy because I also have become very lazy. I don't want to be, typing every now. So you put this and you should be able to log in. I don't know what the issue here is. Okay. I'm not doing something right. So you do SSH, and then you should be able to log in. So that it asks me for my username, password, and I'm going to log in. Yes. So I'm already in the CHPC facility. Now, if I choose not to log in this way and use my aliases or the short form I created, I just do SSH. Instead of typing my username and host name, I just do CHPC because I've named it this way. And it also does the same job for me. Okay, it does the same job for me. So the username and the host name. So I'm also logged in. Is this fine with everybody? Are there any questions? Are there questions?
Not at all.
Yeah,
I'm okay.
excuse me.
Okay.
Hello, can you hear me?
Yes, sir.
Yeah, this last one that you did, to me, this is like you communicating between maybe a gateway and the HPC.
Exactly. Because I don't want to be typing my name every time I log in.
Okay.
Yes.
So with this now, does that mean with the Quantum Mobile we can access a free HPC, or you have an access to a specific HPC? Because this is
So
like South Africa.za.
you would have access to. You
You
would have
must
had
have
access.
access.
Yes. It's not free.
Okay.
You would have had access. You would have a principal investigator that will give you access to it. Okay. So I'm
Okay.
just showing how you can move files from your local to, and everything. So that's one of the things, of the core things we should learn from this. So now, if I want to run job on CHPC, you have to run on this lost staff directory, and you can rename it as you want to. This is where I do my I name it based on the year. So 2024. And then I have this directory already. Yes, I can ls to see what I was doing before so I have a folder that is almost like what I have on my local computer. Convergence. Okay, this one is converge. So, but for the sake of this tutorial, I'm going to put one more. So in convergence, I can put it here. So this is it. These are the folders. So I can create a new directory. You can see that I'm working on the machine like it's my local computer. Let me create C2S for this one. So I go to C2S. Good. There's nothing in C2S. There's nothing in C2S. So now I want to move my script on this is my local computer. I want to move it to the HPC. You can do it. There are so many ways, but one very simple way is just do. Maybe I should just take note of this directory on my cluster. I'll copy it and then maximize my terminal so that I don't so that everybody's following. So I do SCP, the name of the file. This is the script. And then I do CHPC because I have communicated with the HPC in my own language. I don't have to be using Emi as whatever, and put a colon in front of it and put my directory, directory on my CHPC that I copied. Yeah, and then I enter. So it asks me for my username, my password. I put that, and it's already there. So this is my local computer. I've moved it to my supercomputer. So let me minimize this. So if I come here, if I come to this computer, let me clear. I'll have my script. This is CHPC. Okay, this is not my local computer. Okay, now another thing you want to make sure of is where do you have your sudo directories. So you can customize your scripts, the job submission script in your script, or you can separate them, your choice, and run the job. Now all of these parts are the job script. These are interfacing with CHPC. Now, the major scripts I want the job to do starts from, for e-courts, blah, 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 and everything. And yeah, so what do I want to emphasize on here? See, it says that my directory, the pseudo directory that is pointing me to where my pseudo potentials are. For a starter, you can put these dots. These dots means that your pseudo potential should be in the same directory as your input file. So now this is not, I don't have my pseudo potentials here, but I can copy them to this directory just the way I did with my script. So let me try to do that. Okay, so I think, yeah, these are the pseudo directories. So I can copy again, SCP, copying from local to supercomputer. And I can copy as many files at the same time. So I'm going to copy this one for copper, cesium, and Cl. And then I do the same thing like I did. And enter. It asks me for my password. I'm going to put my password there. And you see the files, they would move, yes, all of these has been copied. Now, let me now go to my cluster. So ILS, you see that I have them there. Now, how do you run it in CHPC? Remember, different HPC and different, this is This CHPC, they are different. This one is a PBS. You have a PBS queuing system. They also have like a scratch queuing system. So know the one that works with the CHPC. To submit a job, you just do Q sub, and then you put this, and you see this is my job ID. So it shows me that the job is running. I can check the status of my job using my username. It will tell me the status of my job. I was doing something before now. This was what I was doing before now. Now, this is the job that I just sent. You can see that it is queued. That means it has not started running. Okay, it's not started running. Any question? Because I want to move. Any question?
Okay, hello, Doc.
Yes,
Yeah,
I can hear you.
this procedure of moving the file between maybe your computer to the server, the HPC. I don't know if you know about this WinSP.
So there are many ways.
WinSP is like, yeah, it's an app. I don't know whether you call it an app. Yes, an app. You can do SFTP, you can do SCP with it.
Okay.
So you can move files between the gateway, the HPC, and your computer, as the case may be. Then,
Yeah.
like this process now, I don't know if it
Wow.
is specific to Quantum Expresso. You can do square to know what is running currently.
Okay.
Then maybe
Yes.
I don't know if that's the pattern.
Okay.
Yeah.
If you are using Square, that
Yes.
means the job submission uses batch.
Okay.
So this one is PBS. They are different.
Okay.
Yeah. So they are different. So if it is if it's like I have another machine, if you see the one I shared with you, on SSH, I even had access to Seneca and all of those, but no longer functional. Oh, sorry about that. If you see this, like Morpheus uses the batch, then CHPC uses PBS, even Seneca uses batch. So you just need to know which one you are working with. Yes. So it depends on the one that you're working with, it determine how you will say. But I think that app, of course, would work. But me, I'm like, why do I need an app? I just do this on my computer. I can do SPC. SPC can take data from your local computer to SPC, and also you can also get from the HPC to your local with SPC. You can also do that with SF, I think SFTP. Yes, so that is basically it. So let me see if this job is running. I don't want it to run, but it's already running. So I want to kill it. I don't need it. So that, let me not waste computer. I'm just using this for demonstration. So to kill, I think it's QDEL. Yes, QDEL, and I put to kill it. If I do it again to tell me that the job is no longer, I think so. Yeah, so I've already killed it. Now, if it is on a batch, you use S cancel. So it depends on the machine you are working with. So after doing this, so let me go to the local, because I've done, yes, okay, let me go to the convergence. We have eCourt. So this is the job. Now, some scripts. There's this, I don't know if I shared this book. I shared this book one time with, I don't know if I shared it. It was Dr. Mustafa from during our mini assessment I shared. It's a very good book. Yeah, because some of these
Please share with us.
Okay, I don't know if I shared, but I will share again. Now, it's the first time I saw the book, and the truth is that these are really nice. So look at that script I was telling you of. It's already here in the book. Yes, it's already here. So, but this one, they are doing it on the local machine. So you see all those job scripting parts, that I included were not there. They just started for ECOT, blah, blah, blah. Then what I just wanted to add is that you see this last part of the script, I did not use it. What this does is that it is going to get information relating to this exclamation sign and put them in a column. Okay, put them in a column and then give it a name, which is cal-ecot dot. So I'm like, it's not everything we want to do with script. You can do this thing by hand. So if this is it, after running all of this, you can get all the information relating to the total energy. Just do the exclamation sound sign, and there are so many ways. You can do it this way, you will get it. Because all the energies, the only place where you find this exclamation sign is where you have the total energy. You can also do it grep. Just understand a bit of Linux. You can do grep this, and you say do it from all the files with that ends with .out. You will still get the same thing. You can also do this. I'm just telling you how you can play with this thing. There's no strict way. If you understand, and there are numbers, so I can put 2 numbers. It means that where I have numbers, I will still get the same thing. So play with this thing, understand the basis of Linux, and just continue enjoy playing with it. So if you do this, you will get your ECOT, you get your ECOT. So I'm going to get that file. I'm going to get that file into my local computer. I already have it, but I'm going to try to demonstrate it here. So I'm going to call this, give a new directory and delete it later. C2S in this. So now I want to copy that information I ran on my local, on my HPC. You can do SCP again. The username and host name put together, and then you copy the directory where you have that information. So pwd tells me the directory. So this is it. I copy it, go to my local computer and paste it here. Then of course the file name is ecot.dat. And the difference here is that I put a full stop to say, okay, bring it into this directory. And the same thing works. You do your, I'm not sure I typed it. Okay, I haven't typed my password correctly. So it's already here. So you see ecot.dat is already here. I didn't go to my, I didn't go to the directory that I created to do it, but it's not a problem. So this is the directory I created. I actually like rewrite the file I already had, but it's the same thing, so it's not a problem. So you can do it differently again using that SFTP, like you said. Then you put the file, you go to the directory. So this is it. So I'm on my local computer, and then I have moved using SFTP. This is another approach to my HCP. If I do LS, everything on that directory in my local computer is available here. So if I need anyone I need, I just do get ecot ecot.dat. I just get, I need to get this one. Yes. And you say enter. So mind you, me, I'm working for my local computer, and once I'm done with this, I exit. So I'm done here. I can actually, so I'm back to my local computer. I'm still on my local computer, but I moved it from my local computer. If I do ls, this is what I'm going to have. Now, let's now move to what I'm going to do with this file. So if you open it, if you open this file, this is how it looks like. Yes, I've already removed some information, excess information. So I only have the column for the LAT, ECOT WFC, and the corresponding energies. Yes. And then you use that file that was prepared by Alberto. I keep mentioning Alberto because Alberto was the one that I have never seen with any other person. Alberto was the one that prepared and shared at, assessment. So what does the file? Is a Python file that gives you the energy difference. So what do you need to change with this file? You need to change the file name. You see this name must correspond with the name of your file. If it is equal.dat, if you whatever, make sure you have it there. That's what you should change. Every other thing, leave it this way. Then, of course, save this file. It's a Python script. Save this file with so name. So those are the only two things. And then you run. It's a Python script. So I do Python and I do so this is what it does. So you can see our convergence. You can see this is what we have. Can see the flatness. Yes. And then this is the energy difference. So any value you take around this point, the energy difference is already 0, approximately 0. That means you are not going to be changing everything. So Abato was the one that actually first time seeing this with Abato, and then it's good because sometimes it's not even the shape. Of course, the shape matters, but sometimes the energy difference is what you should consider. Yes, you should consider the energy difference, yes, when you are doing this kind of calculation. And who remembers why? Somebody asked this question the last time. Why is this result? Well, the result of the lowest energy that is obtained for infinity cutoff that we use. Why is it like that? Which governs this whole thing? Who remembers? Somebody asked though. Who remembers? Yes, who remembers? Yeah, which principle? Anybody? Variational principle. And I was so happy, like this morning, going through these documents, I saw it. So every information we need is actually available at our disposal. We just need to, we need to find the information. I'm trying to get the page where he talked about it. And when I saw that, wow, this book is really good. It's good exactly for beginners. It gives you practically everything. Look at it. It says that in principle, the result of the lowest, I don't know why I can't highlight, but then is obtained, in principle, the result of the lowest total energy is obtained for infinity cutoff energy by a variational principle. So you might be curious, okay, what is this variational principle? You want to study more about it. This is how learning starts. Yes, so now the next one we want to talk about is K point. So after you have done that, like this tutorial, this is how their graph looks like. You want to do K point. One information about this book that is really nice, it says if you are doing a three-dimensional object, you would have K1, K2, and K3 values. If it is two-dimensional, like if you are working with a surface, yes, you're going to have K1, K2 by 1. If you're working with a one-dimensional system along Z, it's going to be what? 1K. So you just have like one layer, and then you have, you know, um, you know, 1K for one dimensional. Then if you are working with a zero-dimensional system, the K point you use is 111. So when you see some input file even available online and you see the K point, you can easily tell, oh, this material is a surface. They are looking at the surface. They are looking at, one-dimensional system of this material. You can tell from the K point. And this information is right there in this book. Now, they've also mentioned, based on symmetry, a number of times we don't look at symmetry, but the code needs to understand symmetry. I remember my prof, Idiodi, teaching us about symmetry. It's quite interesting, like this symmetry is another space on its own in theoretical physics. But it's quite interesting because the code understands the symmetry of these different structures. Now, if you are working, like, I can confirm this because I have experimented this in the past. And if I've seen it here, got me really happy because, wow, this is nice. I've seen this before. If you are working with cubic, tetragonal, orthorhombic, monoclonic system, it is okay to shift the K point. I'll explain what that shifting means. Then if you're working with hexagonal, like what we are doing, or trigonal, don't shift. Then if you're working robohendra or triclinical, if you shift or you don't shift it, is also is fine. Let me explain what that shifting is. If you pick this book, you will see what shifting is. Well, this diagram is what I'm just saying. So when you choose the bioline zone you are working with, if it passes through the point, here, can you see there is no shift here? But if you push it such that it is lying between, atoms, then there's a shift. That's just what it means. But basically, it's the same system. But how do you structure, the Brouwer zone based on, yeah, this is actually physics. I don't know how best to explain here. So you can shift from the lattice point, or you can ensure that it passes through the lattice point. So that's what shifting is. And the book has already recommended, if cases where you should shift and where you shouldn't shift. Okay, so now you go to the K point. I think the K point is very important for us. Yeah, because it's hexagonal system. We have convinced ourselves that it's an hexagonal system. So I'm going to just clear up this. So I go back, and then I go to, okay, I go to E-cut roll. Now, E-cut roll, the default value of E-cut roll is, E-cut WFC times 4. But you also need to convert. There are many things you need to convert. E-cut roll, smearing. We don't do it, but we should actually do it. Now, what it means is that after we have obtained our E-cut WFC, we can now do another set of calculation. But this time, we fix the value that we got for E-cut WFC, and then we multiply this E-cut roll by 4, 5, 6, 7, that's it here, up to 14. And then you run the script like we did before. You would have this data. You have this data. And if you look at these values very well, you notice that maybe you are from about this point, nothing is really changing in this value. The difference in energy is about 10 to the power of minus 3 milliriebeck. So really small, which is good. And if you plot it, you will also see that flat part in our, so E-cut roll date using 1 to 2 with lines. So you can see that at this point here, there's almost like nothing changing. This is flat. So any value that you use about this point is good. I've used something around here, which is 320. That's multiplying our E-cut WFC by 10, and I got 320. So I think that is basically it. So what the next thing I want to emphasize is K point, because it's an hexagonal structure. How do you do optimization for hexagonal? So let me just close this. So I'm going to K point. Now you can see that I have different values here. I can remove the first one because I just needed an input file sample for it. Now, this is how the first one looks like. I call it 4. Yes. So just the K point optimization, I have 441. And the question will be, what governs your choice with 441, and how do you choose it? You know this thing, there are so many formulas, but it's scaling. It's just fraction. So when I look at my input file, let me see if I can share. I can't share a whiteboard. So I'll just, yeah. So I'm just going to write on the screen. Now, when I look at my input file, I already know that A is 7.2 Armstrong. Then C, the length of my cell, is about 18 Armstrong. Now, what you can do is that you can take different values. Okay, let's say 30, 40, 50 and on like that, and scale. Remember, in the reciprocal space, the K point is going to be shorter. So I take the first one, you are scaling. Okay, you say, okay, remember you want to work for KX, KY, and KZ. This one is KZ will be shorter. So I say 30 divided by 7.2, 30 divided by 7.2. Then, what's the ratio of C to A? If I do ratio of C to A, 18 over 7.2, this should give me like 2.5. This is give me like 2.5. So whatever value I get from here, I'm just going to multiply by 2.5. So please, someone can help me check. So if you do the first one, let's say by 30, well, let me do it on this computer. So 2.5. Let me try to, there's a calculator here, BC. So I have
That's about 10.41.
Okay, so 30 divided by 7 point, sorry, 7.2, 4 point, yes, 4 point something. So you know what? I'm just going to take the integer before the decimal point, 4. So for this K point, KX is going to be 4. Now, to work with the last one, I think it's going to be the same thing. Yeah. So 30, that's scaling. 30 divided by 18. Let me see. Yeah, so 1. I won't say 1. Approximately 2, but I'll just say 1. Okay. There's another method someone taught me, and I've used both of this method. I'm like, okay, why should I be using a formula? This also works. So if I scale it without considering the numbers after the decimal point, I'm also fine. So if you do this with 30, 40, you're going to get 4, 4, 1. You get 6, 6, 2. You get 8, 8, 3. You get 10, 10, 4. You would get 12, 12, 4. And then you get 16, 16, 16, 6. So you have to do all of this, and then you check the energy difference and just check where you have good convergence, and that's it. So if you have your K point, you have your E cut, then you now do a VC relax. You do a VC relax to like get the optimized A and C. The last time somebody asked, how do you get A and C, because they are different? And I said with quantum Expresso, you just do a VC relax and you get A and C.
Light. You always argue with me. One day I will just give you slap. You always argue with me. I will give you slap one day. Over Sabi. You always argue. Is it right you are consuming?
Mute that person.
I will give you one
Yeah,
day.
I don't. Where is it?
That's a domestic. Just mute the person.
Okay, so that is basically it. So you do ABC relax and you get the values for A and C from the output. It's almost like automatic. And so from that you can actually I've muted him. So you can now do your bounce calculation. So those are the basic things. And don't forget our bounce calculation, it starts first with a PW.X for SCF, then you do a PW.X for NSCF. Yes, the final thing I really need to show, like this is practically, what else do you need? You don't need any. So now your K point. How do you choose K point? Sometimes there's this book by Cotorolo. Then we go to the book and you begin to check the, now with what's it called? Materials cloud, you can get the K point. So if you see here where you have tools, work, and there's work, you can get the tools, you can go to tools, and then you choose K parts. So which K part are you going to use when you are doing your second calculation? The bounce calculation, there are 3 phases. First one, PW.X SCF. The second one, PW.X with NSCF. That NSCF, you are not going to be using K point, more compact grid, but you are going to be stating the symmetry point in that. So now what you can do here is go to the input file. Yes, I think this is it. And then you calculate. This is one way to do it. There are so many ways. Now, this is like the Brownline zone of the system. Not sure why, if it's the network that is okay. It says I should wait. So it should actually, maybe it's loading. Now I do this, but then I also use Airflow to also do it. I think I like Airflow, but let's just compare. And I think that's where we'll stop today. Why? Come on, show me what I need to see. Okay, good. Now, you see, it's giving me suggested K parts, symmetry parts. It has already told me gamma M, K, gamma A. You don't have to go through all these parts. Okay, just choose maybe a few points. Gamma M, K, M, gamma M, K, gamma AL, and H, and that's fine. And how do you get the points? This is gamma. Then there's M. No, sorry, I think it's here. Yeah, there's M. This is M. So you just pick them like that, and then you put that. So the second way I'm going to show, I like this one very well. Also, Davide was the one that Professor Carasoli was the one that, showed this part with me with Airflow. So how does it work? I'm going to demonstrate that, and I think everyone should be able to complete the exercise. Now, if you have a quantum Expresso input file, you can convert it to an input file that is readable by verbs or whatever and everything. Yes. So now if I have this quantum Expresso input file, SCF, I do excrease then SCF. This is it. This is what we are trying to optimize. Can see that it's big. Okay. Now I can just save this as what? XSF. Okay. Save it and just save it. I have it saved already, so I'm not going to do it 2 times. Save it in the directory and then you have it there. You need it for Vesta, like Vesta. So this is the file. I think it's in bands. I save it in bands. So this is how the file would look like. XSF. So this is how it looks like. Now, if I need to open, I started with Quantum Expresso, not the C file. If I want to open it with Vesta, so I come to Vesta. I already have Vesta installed. I open. I go to where I have it. It's one of my shared folders, projects. This is it, bands. And I open
Dr.
my
Rita, you are still showing the materials cloud stuff.
Wait.
You are not sharing that.
Oh, so thank you for letting me know. So this is my XSF file. So I can move from a Quantum Expresso file to an XF file that Vesta can read. If I go and upload my XF Quantum
Please,
Expresso input file.
sorry to cut in. Is this
Yeah.
Vesta doing the same thing as the Chris the X Chris then?
Yes. But with Vesta, you can export the file to any format that is readable and any code. You can see this one. This one, you can convert it back to C file. You can convert it to what? A VALS file. So you can do, Vesta is more robust.
Okay.
Esquiden is more for like, okay, for Quantum Expresso. But if I want to work with, other ab initio
Okay.
codes,
But is
I
it
can
embedded
also,
in the Q mobile
yeah,
as well? The Vesta.
no, you can install. No. But it's very easy to install it.
Install.
So
Okay.
when you do that, it's very easy to install it. So when you do that, I'm going to have like, let me clear all this. I'm almost done. Now this is the file I saved with this. I exported it to VALS form. Now, why is this important? We are talking about K points. We're talking about K point. And I say, okay, you can get the asymmetry point maybe from Materials Cloud or from any other way. Me, I like this one, So just know what you like. Airflow also does that for you. So if you do Airflow, don't forget, all these things I'm telling you, I'm just somebody that is just privileged to have enough on me on my head. So, yes. So this is somebody teaching me all of these things. Davide told me this. And see, you see all my key points. So now what I want us to do now is compare. I'm going to compare. So I'm sharing, I put side by side Ubuntu and my, can we see both of them side by side? Can we see the two pages, my browser and then my terminal side by side?
So it's only one we're seeing.
Okay. Okay, I was trying to put them side by side, but I'm not sure. Anyway, so this is how it should look like. So you see, I just copy here, gamma. I copy one of these, okay, M. Then there's K. There's another gamma, just copy. And then there's A. There's L. I don't need to go too far, to get my band structure right. So it has also it shows me that it's an hexagonal crystal and there are 20 grids. So you don't have to go through all of these. So just pick a few and that's basically it. So when you do that, you run your bands, yes, for the post-processing, and you have your band structure. Yes. So that's it. So any question? We are done.
Thank you so much
Thank you,
for
Doc.
the,
Okay, let's pause.
for the presentation. So if I may ask, I want to ask a question because when you are using the normal Quantum Expresso, when you partition, it involves a lot of storage space. How about with the Quantum mobile? where does it store the output file? Is it still on your hard drive? Or what happens?
Yes.
It's the same thing.
Yes, it's there.
Okay.
Yes. So it's even advisable to move when you have finished a job. It's advisable you move it. And one thing you should delete those. There's this temporary files where you have the stored wave function. They always delete it. That's where the bulk of the
Okay.
stuff are actually saved. Let me see if let me see. Even on your clouds, on your HPC, always delete it. When they send messages that storage is almost up, this is what they are trying. Dr. Thomas, you can go ahead and ask your question while I open the CHPC.
Okay, ma. Okay, this is a question. I want to know at what point do we know that, okay, from my experience in running, maybe just like normal molecules, for example, using like OCA, if the memory is not sufficient, the output result will show you that memory is insufficient, and you will know that I will know that my laptop cannot handle this. Then sometimes with some molecules I've worked with, I will know by experience the number of atoms that is contained in it that can run on my system, and the one that would need HPC. So in the case of running with Quantum Expresso now, via the Quantum Mobile, how do we know that this particular crystal will not be able to run, this particular system cannot run on this Quantum Mobile that will need a HPC? Is it when we get the output result, we get an error, or there are things we should look out for? Then secondly, this example now, because from what you've been demonstrating, you run it on the HPC. Does that mean we cannot do it on our Quantum Mobile? We'll have to
You
need
can
access
do
to
it.
it?
No, see, the
Okay.
thing is that my system, you have to know your system that you're working with. There was a time Professor Olayinka and I were doing something and his laptop crashed right when we were just having that conversation. He was trying to import another version of Quantum Mobile when he already had two for that system. Now, my system is not a graphics, I don't know much about hardware, but systems with graphics card, for gaming, they are stronger and they can actually do more robust stuff for graphics. Yes, if you have such system, my former system was an Alienware, and if I run if I run calculation on my Alienware can stay for 2 weeks and nothing is happening. Don't try it with HP. Your system will be making beep, 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 beep. So you have to know the capacity of your laptop. Then the RAM. This laptop I'm using is 22 gig RAM. So it's fast. I can do stuff here. But because I have access to these things and I know what I want to do, I just don't bother to do it. It's not like you cannot do it on your laptop. And also because why I don't do it here, and this kind of what's this kind of laptops that are really spontaneous to touch? SSG, whatever.
No, SSD. Yeah, SSD hard drive.
SSD.
Not
Yes,
HDD.
they are very sensitive. Oh, they are really sensitive. They are very fast blue. You just to touch and they are responding, but they are also very sensitive. Then you also need to check. Most of these SSD computers don't have large memories except you upgrade. So if you upgrade and you have enough space, okay, no problem. But if you cannot upgrade and you are using SSD, you have to be moving your stuff. And SSD, my experience, you need to be shutting down your laptop. So if you are using SSD, is this HHD? I mean, is it HHD, Prof?
No. You see, if it is HDD,
HDD.
HDDs are not rugged because they are just the old hard drives. But recently,
They are
that's the
strong,
recent
oh.
technology. Is
They are strong.
solid state hard drive. That's the SSD. They are very robust and very long lasting. I've been using
Well,
SSD. I just hibernate my system. In fact, maybe once a month. In fact, at times 3 months, I don't shut down my system.
but Prof, me, I had issues with my own
Well,
laptop, like
it
using the
depends.
SSD.
If
So
you
that's
are
what
if you are running something, you can't do that with it.
yes, that's what I'm
If you are not
saying.
running anything,
Yes.
if
Yes, if you
something
are
is
running, if you
running,
are running a simulation,
if something is not
you can't
running,
leave it.
because
Yes.
those things are stored sequentially on the hard drive as it's running.
So
So
yes,
if you
I'm
want
not
to shut
exact.
down as it's running, that means you get it confused.
Yeah. So if you are doing simulation on SSD, make sure it's not something that is that will take too much of
Long. Yeah,
time.
and
Yes.
if I may come in, Dr. Daniel, I think the major thing is whenever you want to compute any compound, the first thing to look at is that you need to check the number of atoms you are working with.
Yes.
Because the larger the atoms,
In more computational time.
the more computing hour that is required. So it's also important. Also, the kind of pseudo potential you are using.
Yes, and the K
So,
point, your choice of
the
K
point, yes, the K point especially.
Your choice of
So the number of atoms
yes.
is very key. Because when you look at, if you are working with larger atoms, that if you look at their atomic radii, it is very large. So it takes a longer period of time for you to relax it and for you to do some of those things. Also, whatever parameter like the K point, like she mentioned and so on, they are very key. So I think it's always better you work with smaller atoms if you know your computer is not too powerful. But
If
what I
your
advise
computer can
basically,
stand, no problem.
is if you can get a computer that is Core i7 and about 16 gig RAM,
yes,
with SSD, 512 to 1 terabyte. They are
16,
expensive, but it will
32.
still do
Yes,
with
you are
little
good.
atoms. But once the atoms are getting larger, you need an HPC.
So
You require an
yes,
HPC.
please. So your computer is what determines, yes. But all the simple ones, you can try them on your laptop. If it's memory stuff, it will truncate it. Yes, it will truncate it. So let me just show you an example. This is what I was trying to say. You see this temp folder? This is where the wave functions are stored. So if I go to, you need to keep deleting. But if you are doing a post processing, that means a calculation that is sequential, you need to keep it until the end. Yeah, but if it's just individual, you see all these things, they are taking space. Like they take a lot of space. So you need to delete it. Either you set it in your input file to delete it immediately after every calculation. But me, I usually I channel it to a folder and then delete it once I'm done. I delete it once I'm done because those are the things, this temp folder where the wave functions are stored and where the cocoa, that's where the bulk of the stuff is. If you can delete them, you are good. You are good. I'm sorry, I think I've spent more time. My time is reading 11:18, and I know it's Nigeria is 12.
It
So
is
I'm
also
just like, okay.
11:18. It's 11:18 where I am. So
Is it 11? Okay. So, but I'm sorry because I don't know. People have taken a long
it's
time.
12:18 in Nigeria. Mine is reading 11:18.
I missed it.
It's
I
fine.
missed it. I just looked at the time. I'm like, hey, Umamu, you are not there. So, yes. So we should have ended by, yes. So please, any other question, please, so that we wrap up.
So
And please,
my
we have gone this far.
own demand is all these recordings, the last one we had last month and this one, I hope it will be made available to us.
It's on YouTube, sir. Prof is very efficient with that too. Prof is a techie
It's on
person.
YouTube. Maybe
Yes.
I missed the what is it called?
It's on YouTube. It's on YouTube. Yes.
Okay. Maybe you send me the directory, please.
Yes. If you check on YouTube, C2S, you will see it there.
Okay.
Yes, it's on YouTube.
Okay,
Yes.
thank you. It's okay.
So any other question? I think now what I want to see is just an email. I have the band structure. Please, I want to see it. Yes. I want to see the band structure for yes. Then For the person working with Thermo PW, can you please send me personal message? Then we work through it. Yes, so because of the time, please. If you're having issues with Quantum Expresso, installing Quantum Expresso, you see, it's one library. One library is missing here, one library is missing there. That's it. Once you have all the libraries complete, you'll be able to install smoothly. Yeah, that's why I always encourage, why not use Quantum Mobile, where all the libraries are there. Even the one that supports your Thermo PW, you will not be having issues installing, Thermo PW on it. Yeah, that's always the challenge. Always the challenge is that one library is missing. You need to get it to have your Quantum Expresso working. So if there are I want to appreciate everybody.
Okay, just to remind you of the book you say you're
I want
going
to
to
appreciate.
share.
Yes.
Yes, and I
Yes.
think if you
I'm
can get
going
the
to, yeah, immediately.
yeah, and if we can get the recording too in the coming days as soon as possible, so that we can start following up to practice, then work on this assignment and get send reverse back to you to be fine. Thank you.
Okay. Yes. Yes. So Prof is
Also, I
traveling.
want to add, Dr. Rita, the person working
Yes,
with
sir.
Thermo PW, from experience, the Thermo PW works with lower versions of the Quantum Expresso.
Well, I don't know about the versions anyway. But I
Most
know.
often, because I remember my student had similar issue. He had to get another PC
Okay.
and install the lower version of Quantum Expresso, not the
Okay.
Quantum Mobile. So it works better with the lower versions, most
Okay.
often.
So even if you have Quantum Mobile, you can compile a lower version of Quantum Expresso. I know it
Okay.
works. I know it works with 6. I know Thermo works with 6.4. That's what HPC is. For 6.41. That's what
Okay.
HPC has. So
Okay.
if you have your Quantum Mobile, you don't need to get another PC. Compile another version of Quantum Expresso in that your Quantum Mobile. Me too, I also have other versions of Quantum Mobile, Quantum Expresso in my Quantum Mobile. Then you compile the Thermo PW with respect to that one that you compiled, and it also works. Yes. So if there's nothing, we want to appreciate FETs, sponsors, the Zoom, University of Colorado. Yes, we want to appreciate them, because all this access is through, the fellowship that Professor Lainka has with them. That's why we can have this Zoom meeting, unlimited and everything. So we want to appreciate them for this opportunity. I want to thank everybody for being present. Thank you for supporting, yes, this project, and we trust God that it's going to get better. Yes, all your observations you can send through mails, then maybe we'll do a Google Drive, like where we can collate information and then we can use it, for going forward. If you have suggestions on what we should do, you can also put it there. Then Prof, after now, we'll begin to talk about the funding, and we
Yes,
trust
yes,
God
yes.
that
Yes, we need to.
something
It's actually a laudable program.
we come out of it. So hi from my
Sorry,
name.
dog, before you sign out.
Okay.
You were saying you wanted to show us the book now, but we've not seen the
I
book
will
again.
share. Are you on the WhatsApp? Let me do. Should I do it here? Should I attach it to this Zoom meeting? Or I should do it on
I
WhatsApp?
think it's better to share on the WhatsApp group.
I'll share it immediately. Yes.
You can add him to the WhatsApp group.
Okay. Are you on the WhatsApp group, please?
Yes, I am.
Okay. So I'm sharing. In fact, I'm sharing. Let me share it now. Yes. So if there's nothing else to say, to discuss, I want to appreciate also Dr. Mustafa for sharing that book, because I've never seen it too. Like I've never seen that book anywhere. Yes. So it's whoever that wrote the book really took their time to compile it, and I want to appreciate people that share this information, because you can see how we are transferring knowledge from, one hand to another.
Okay.
Yes. Yeah. So that's it.
Yeah.
Bye. Bye.
Okay.
Thank you.
Yes.
Where am I?
Enjoy.